Okay, students, today we're going to solve rational equations. Again, rational means anything written as a fraction, usually an algebraic expression. Okay, an equation has an equal sign in it, and then or inequality has an inequality sign in it. Okay, so there are two ways you can do it. I prefer doing it the way that they show here, which is to go ahead and clear the denominator. I could get a common denominator and then make equivalent fractions for each one. Okay, and then set the combine like the terms. I could then cross multiply, set equal each other, or I could just put the numerators equal each other. But what they do here, instead of dealing with all that and having the denominator still there, is they multiply the entire equation by the common denominator, also called the LCM, as we've already dealt with. So we have three factors here: a 10, x plus 1, and a 5. Well, 5 goes into 10. Okay, so you got to have at least the 10, and then the 5's already taken care of in that, and then you have to have the x plus 1, that factor as well. So there's our common denominator, 10 times x plus 1, which is what you see right here. So they multiplied both sides of the equation by 10 times the quantity x plus 1. Okay, uh, so what do you get when you distribute this through here? Well, the 10's cancel, and you're left with 9 times the quantity x plus 1. Okay, so that's what that is. Then what happens when you distribute this through the second one? Well, the x plus 1's cancel, so you just have plus 2 times the 10, which is what you see right there. Okay, so that's why you have on the left side, and the right side, it was 2/5 times that. Well, the 5 is going to cancel with the 10 2 times, and then you have 2 times that, 2 right there, 4 times the quantity x plus 1, which you see right there. So in this example, they did a very good job of not skipping any steps. So then you go ahead and distribute it, get 9x plus 9 plus 20, and distribute property here. Okay, combine like terms and subtract the 4x across. 9x minus 4x is 5x. 29, so you subtract 29 across. 4 minus 29 is negative 25. Okay, so you have 5x equals negative 25, x equals negative 5. Now, we always have to check in rational equations is whether this negative 5, the answer, will make one of the denominators equal to 0. Okay, obviously I can only plug it in for x, so there's only this one I'm really checking it all. But if there's x's in the other denominators, I have to check all of them. And if that negative 5 made it equal to 0 in any of them, then it would be an extraneous solution. It does not here, so x equals negative 5 is a solution. Okay, they went ahead and actually plugged it in and checked it. But first thing I would automatically just do is just check to see if by plugging it into the x in the denominator, or x is if there's more than one, if any of the denominators count to be 0. If it doesn't, it should work. Okay, unless you did your math wrong. Then you're not confident of that, then you go ahead and check it. Okay, and it can work that way as well. Okay, so that's what you're doing on this one right here. Okay, the other way, if you have just one rational equation equaling another, I can just simply cross multiply. Set equal each other, so proportion. Okay, don't forget I have two terms there, so I need to have parentheses around those, so I make sure I distribute. So you could then cross multiply, set them equal each other, and do that if you want as well. Okay, but the idea would be multiply by the common denominator between 5 and 3 is 15, distribute the 15 through. Okay, all right, backside now. Solving rational equation inequalities. State the excluded values. Excluded values means what can't be. That means when what will make the denominator equal to 0. Well, in both these cases, it's n equaling 0. So the 0 cannot be an answer. Okay, can't be in the domain. Solve the related equation. Okay, so then solve that. Use the values from step 1 and step 2 to divide the number into regions. okay, and test the value in each region to see which regions satisfy the original inequality. Okay, so we have 0, it can't be. So that's a region. You solve this, multiply by the common denominator, be 15n. Okay, that's what you see right here. 15n on both sides. Distribute, you get this. 10n equals 22, n equals 2.2. So now I have 2.2 also, right there. So my regions are less than 0, between 0 and 2.2, and greater than 2.2. I want to test one from each region to see which will make it true. Back into this original here. Always back into the original. So if I take 1, for example, I want to pick a nice number to plug in. 1 for that one. 3 times 1 is 3. That's 5. Okay. So common denominator would be 15. Okay. 15 divided by 3 is 5 times 2 is 10. Plus 15 divided by 5 is 3. Plus times 4 is 12. Is that less than or equal to 15 divided by 3 is 5 times 2 is 10. So it's 22 less than 10? No, it's not. So this is a no, so it's not in that region. Pick 3 now, for example, there, for that region. 3 times 3 is 9, 5 times 3 is 15. So again, and a 3 there. So 45 is going to be a common denominator. 5 times 2 is 10, 3 times 4 is 12, and 15 times 2 is 30. Is 22 less than or equal to 30? Yes, it is. So this region is a go. And let's try -1 for the last region here, which makes it -3 and -5. Again, multiplied by 15, common denominator. That's -5 times 2 is -10, plus -3 times 4 is -12. Is that less than or equal to 5 times 2 is 10? Is -22 less than 10? Yes, it is. Okay, so I've tried all 3 regions, and so my answer, I have to identify those regions right there. Okay, so the solution is n is less than 0, because this is the region that worked, or n is greater than or equal to 2.2, because it was true in that region also. So that's what you have to do with inequalities. Okay, so you got to identify what will be the excluded value, and that becomes one of the markers you put down for the region. Solve the equation, put that other, or if there's 2 of them, put those markers down, and then you have to try numbers in each region to see if it's true or false. Okay. So there we go with that right there. Okay, so that is this side. That was the only example we need to go through, right? Yes. Okay, so that's what you're checking right there with that. And that was the second page, right? Yes, it was. All right. 8.5.